Hello and welcome to the post-lecture video for section 4.2, covering the closed interval method.
When we talk about the closed interval AB, we are taking all values x, where a is less than or equal to x, which is less than or equal to b. The word closed is used because the endpoints are included in the interval. Contrast this to an open interval AB, which includes all values x between a and b, excluding the endpoints. These are open in the sense that we cannot find the first value and the last value in the interval. Our focus in this video, the closed interval method, is a consequence of the extreme value theorem. The extreme value theorem says that a function f on a closed interval AB attains an absolute maximum f of c and an absolute minimum f of d for some numbers c and d between a and b. It is critical that the function be continuous. This function has a jump discontinuity exactly at the values we would consider to be the absolute extrema. The y value of c and the y value of d are never attained. In fact, the range of this function is the open interval dc. The largest value of this interval cannot be found, for it is the highest value which is just below c, a value which does not exist, as there is an infinite number of values between c and c minus 1. We conclude that this function does not have an absolute maximum value, and for the same reason, it does not have an absolute minimum value. This function has two removable discontinuities and no absolute extreme values. If the holes in the function were filled, then the function would have absolute extrema. This function has an infinite discontinuity, so the range of values is unbounded. Therefore, the function does not have an absolute extrema. Not only does a function need to be continuous, but it must be continuous on a closed interval. This decreasing function is continuous on the open interval AB, but does not have an absolute extrema. If the function were continuously extended to the values a and b, it would have absolute extrema at f of a and f of b. The extreme value theorem is an existence result. It guarantees the existence of absolute extrema, but it gives you no insight on exactly what those values may be. Once a function is known to be continuous on a closed interval, we can find the absolute extrema using the closed interval method. To find the absolute extrema, we find all critical numbers of the function which lie in the domain, and compare their y values to the y values of the endpoints. The most extreme values among these y values are the absolute maximum and minimum values. Take, for example, the polynomial f defined on the closed interval 0 to 3. As polynomials are always continuous, and we are on a closed interval, the extreme value theorem guarantees an absolute maximum and minimum value in the interval 0 to 3. The first step of the closed interval method is to find critical numbers in the interval. We take the derivative of f and factor. Remember that critical numbers are the x values for which the derivative is 0 or does not exist. Since the derivative of a polynomial is defined for all x values, the only x values of interest are -2 and 1. Be careful and don't jump to step 2 at this point. X values are critical numbers only if they are in the domain. As the domain of f is 0 to 3, x equals 1 is our only critical number. In step 2, we collect the x values from step 1 and the x values of the endpoints, and we plug those x values into the function f to calculate their y values. For step 3, we have an absolute maximum value of 49 and one absolute maximum point, 349. We have an absolute minimum value, -3, and one absolute minimum point, 1-3. To summarize, by the extreme value theorem, continuous functions on closed intervals have absolute maximums and absolute minimums. Further, we find these values using the closed interval method.
You've seen the basics, now gain mastery through practice and study.